In this video, we're looking at 2022 paper 1 question 2. The first half is integration and then there's a simultaneous equation at the end. We're given g of x is 2x squared plus 5x plus 6 and we're asked to get the integral of g of x. In other words, integrate 2x squared plus 5x plus 6. This is relatively straightforward. If I need to integrate, remember that means you increase the power of x and divide by the new power. So the integral of 2x squared is 2x cubed divided by 3. The integral of 5x to the power of 1 is 5x squared divided by 2. The integral of 6 is 6x. And remember, since there's no limits here, we do have to add in the constant of integration of plus c at the end. So that's our final answer for the first part of this question. Okay, now B part I is a little bit more challenging. We're given a quadratic curve here. We're told that it can be written in the form ax squared plus bx plus c. And to the right of the y-axis, it's divided into 3 regions. From x equals 0 to x equals 2 is k, from 2 to 4 is L, and from 4 to 6 is N. We're told the area of the region marked k is 538 units. And we're asked to write this in a specific form. Now you should recognize that we can use integration to find this area. If I can find the area between the curve and the x-axis from 0 to 2, then that'll tell me the area of k. And obviously, since I know that's 538, I'll be able to come up with an equation. So remember, when we were doing integration, to get the area between a curve and the x-axis, you integrate the curve. In this case, the curve is ax squared plus bx plus c, and we're going to integrate it using the limits from 0 to 2. That'll give me the area between the curve and the x-axis from here to here. So my limits I'll add in is from 0 to 2. And remember that I know that the area, I know that that is equal to 538. So if I simply integrate the left-hand side, I should be able to come up with the equation that's stated in the exam paper. So essentially, we're trying to integrate the curve from 0 to 2. If we integrate ax squared plus bx plus c, well, the integral of ax squared is ax cubed over 3. The integral of bx to the power of 1 is bx squared over 2. The integral of c is cx. We don't add a constant of integration this time because there's limits. You don't add the plus c at the end. If I'm subbing in my limits, I first sub in the upper limit, which is 2. So here, instead, I've rewritten all of this, except instead of an x, I've subbed in a 2. Then I put a minus, and I sub in the lower limit, which is a 0. And that, I know, is equal to 538, because this works out the area marked by k. All of this is just becomes zeros, because anything multiplied by a 0 is just 0. So 2 cubed becomes 8, so I get 8a over 3, plus 2b plus 2c equals 538. Now you might get a bit confused when you get to the second last line because the question asks you to leave it in the form 4a plus 3b plus 3c equals 807. So probably the easiest thing to recognize here is, well, here's a 2b and here's a 2c, and both of them have to become 3's. In order to turn a 2 into a 3, I multiply it by 1.5. So I recognize that, and then if you plug it into your calculator, 8 over 3 multiplied by 1.5 is 4. 2b multiplied by 1.5 is 3b, 2c multiplied by 1.5 is 3c, and luckily 538 multiplied by 1.5 is 807. So that gives me the answer I was looking for. In B part 2, we're given 3 equations. The first one is the one we worked out in part 1. And the second one is what we would get if we worked out the area of the region marked L. The third one is what we would get if we worked out the area of the third region. Ultimately, we're left with 3 equations with 3 unknowns. So we just have to do a simultaneous equation here. When you have 3 equations and 3 unknowns, I always recommend labeling your equations. So I'm labeling the first one as x, the second one is y, and the third one is z. Obviously, there's a number of different ways of doing these, so if you didn't do it the same way as me, that's fine, you should just get the same answer. What I decided to do was to take the first equation and the second equation, but change the signs of the second one. And when I did that, the second one becomes minus 28a minus 9b minus 3c equals minus 879. And when I add the 2 equations together, I get minus 24a minus 6b equals minus 72. This is my first equation that only has 2 unknowns, so I'm labeling this as a new equation, and I'm calling it equation W. Then I've basically repeated the same thing again, except this time I'm taking the third equation and I'm changing the sign of the second equation. Since in these two I got rid of the c's, I want to get rid of the c's again. So when I change the signs of the second equation, the c's cancel, and this time I get another equation, 48a plus 6b equals minus 216. This is my second equation that only has two unknowns, so I'm labeling this as equation v. I notice then that w has a minus 6b and that v has a plus 6b. So I simply take them down beside each other, the b's cancel straight away, and I end up with 24a equals minus 288. And in order to get a on its own, I simply divide everything by 24. So now that I have a value for a, I'm going to go back, I'm going to sub it into this equation, and I'm going to get a corresponding value for b. When I have a value for a and b, I'm going to sub it into the first equation, and I'll get a value for c as well. So we already know equation w is minus 24a minus 6b minus 72, and a is equal to minus 12. So instead of a, here I've just subbed in a minus 12, and you end up with b is equal to 60. Once I have a value for a and a value for b, I subbed into the original equation and I got the corresponding value for c is 225. So that's your final answer for the last part of this question.